Okay, went ahead and started recording, and so we'll go ahead and get started. Chapter 8 is a another foundational, fundamental chapter in programming in general, not just in C sharp, right? So, I was kind of thinking about the lecture that I have to give today, and I was thinking about arrays and what I want to talk about. And right off the top, you're going to learn these two concepts in this chapter, which are arrays and collections. And so what you'll learn about arrays is that arrays are pretty much, I mean, this is overreaching, but they're pretty much the same in most languages. Again, that's a little bit of an overreaching statement, but you're going to find arrays in JavaScript and in Java and in C Sharp and in Python and in Ruby and blah, blah, blah. You're going to find arrays in every language, just like you're going to find loops in every language and if statements. And there's going to be syntax differences between the languages, and there's going to be differences, but they're there, right? Arrays are there. And they've been around forever. But then in C Sharp, there's kind of something newer than this concept in an array, which again is an older concept that's in every language, and these things are called collections. And in a lot of ways, collections are better than arrays. And so, like, just even looking at this slide, it makes common sense to say, okay, well, why would we learn the old stuff? Like, why would we learn arrays? And I would answer that kind of in two ways. I would say, number one, arrays are in every programming language that you're going to study. And so you're going to see them. So we can study kind of the newer things in C Sharp, and certainly we use a lot of collections, not only in this class, but in our curriculum as a whole. And we're going to talk about their benefits and, again, how they're better than arrays. But that doesn't give us the pass to just ignore arrays and not understand arrays just because there's something newer. Arrays, again, are in just about every language, and you cannot escape them. Right? And so when I was thinking about this to myself, I'm a fan of the Marvel movies, like I'm sure many of you are, right? And it just reminded me of a silly quote, right? And if there's one thing, I was like, maybe my students will remember this because it's a Marvel quote, right? So, of course, the big villain of the last genre of Marvel series was Thanos, right? And what was his big quote? He would say, "I am inevitable," right? And so, yes, arrays, I'm going to quote, arrays are inevitable. Arrays are inevitable, just like Thanos, because you're not going to escape them. They're going to be, even though right off the top of the bat, we're going to say, hey, we've got these newer things in arrays and they're better. But that doesn't mean that you cannot learn arrays. You must learn arrays. Arrays are inevitable, like Thanos, although at the end of the day, he went into dust, maybe, but he served his purpose. Okay, moving on. He did get an axe to the head.
Thank you, Thor.
Arrays are inevitable. End of the lecture. Have a good day. Talk to you later. So what are arrays? We've learned what a variable is, right? And a variable holds a single piece of information. Like if you have a first name, you can store a first name in a string. Or if you have an age, you can store an age in an int. But I want you to imagine quickly, like, just inside Rankin. Okay, inside Rankin's a piece of software. Rankin pays for this piece of software. Like many softwares today, you pay like a monthly subscription or a yearly subscription. So Rankin pays this company. The software is called Genzabar. Okay, so we pay for this subscription to Genzabar, and we pay it for a yearly basis. and we collect all of your information, like your student information, and we store it on this software. We store it in this software. Well, you can imagine in this software there's going to be variables, right? And so there's going to be student names, right? So behind inside Rankin, somewhere we're storing student information, we're storing student names. So somewhere there's going to be, again, variables storing your information. So I want you to imagine a software program, and granted inside Rankin doesn't look exactly like this, but something like this, right? Let's just say in Rankin, we'll spitball, it has 2,000 students, okay? Across all programs, day, night, whatever, Rankin has about 2,000 students. So I want you to imagine string student name 1 equals Bob. String student, and maybe it would be student first name, right? Student first name. If you wanted to do student full name, but you get I'm just going to go with student first name, right? So, Jan. Okay, student. You see where this is going, and even in some of the labs, you might have noticed like these labs that we're building now aren't very scalable. They're not very scalable. Like, okay, if you have 3 employees and they have 3 salaries and then they have a raise and you have 3 more variables to store their first raise and they get another raise and then they get another raise. Like, can you imagine all these variables that you would create if I'm just going down this? If I have 2,000 students, I'm going to have to create 2,000 variables to store their first name. Okay, let alone if you have another variable for their last name, let alone if you have another variable for their age, right? Just doing the math behind that, you're talking about tens of thousands of variables very quickly. Okay, you're storing a lot of data. And so that's creating our programs in this way with all these singular pieces of data stored in singular variables becomes very, well, it's not scalable, right? I don't know what you would say, very, very flat. It won't grow, right? It won't grow quickly, yeah.
I don't know if this is off topic or not, but I'd like to petition for Inside Rankin's website to include a search bar.
Fair.
That would make life so much easier.
Yeah. So, Inside Rankin, let's just, what is that? So this is like an off-the-shelf product that we buy, and then much like Windows, very much like Windows. Like, you buy Windows, you get the updates that they give you, right? You're kind of stuck with whatever Microsoft says is going to be in the next patch. You get what you get, and that's very much what we get with Inside Rankin. Like, we patch it, we keep it up to date, we get the features, we implement the features that they make available to us. It's acceptable, but it's not good, right? I would say Inside Rankin's acceptable, then it's not good. And if you've ever been to another college, like the competitor to Genzabar is called Blackboard, and students really dislike Blackboard, right? So as much as you may not like Inside Rankin, if you've ever seen Blackboard, I've heard many more complaints about it. Moving on, so singular variables to store single pieces of information isn't scalable. So now, how did that? I don't know what hotkey I pressed there. So there's another storage unit. If you think of an array as a storage unit of information, or a variable is a singular storage for a single piece of information. Whereas an array is more like a warehouse where you can store a lot of information in an array, right? I'm thinking of how many people you got stuff, and so you need to rent like storage lockers, right? A single storage locker can store let's just say one person's stuff, but you can have many storage lockers to store a lot of information. An array can store lots of pieces of data. Okay, it's not just a singular piece of data, it can store a lot of data. So think of it as a storage container that can store many pieces of information. So in my example of student names, let's just say Rankin has 2,000 students, I could say something like this. Now, why does that do that? Literally, okay. String. Student first names. So the first thing I want to point out when I have an array, I've got the brackets. So when you see brackets kind of yell, it kind of signals, it yells to you that we're working with an array. And so now I'm creating this array called student first names. Notice the camel casing. Notice the brackets. Okay, so we have now declared an array. How many pieces of data can we store in this array? We haven't defined that yet. So remember, there's a declaration like such, just like when we're declaring variables, right? What does it mean? We're giving it a data type. We're giving our array a data type, and we're kind of making space for it in RAM. Okay, we're like saying, hey, there's going to be some storage here. But we haven't done the second half, which is the assignment operator, right? We haven't, or in other words, you might want to initialize your array. So the assignment operator, or the initialization process, is you're going to have this equal sign. And before I even do that, I want to make this point. In C#, it's different than JavaScript. Why? Well, in JavaScript, we had, remember let, and we had const. And with let, you could store a name in there, you could store a number, you could store a Boolean value. Line 7 says that this array works with only strings. So in C#, our arrays are strongly typed. Okay? So we can only put strings in here. So our arrays, just like our variables, have data types, and you can only put that data type into that array. Okay, which is different than JavaScript. In JavaScript, you could put a number in it, then you could put a string in it, then you could put a Boolean in it, then you could put a char in it, and JavaScript's like whatever you want, just put it in there. That's not how it's going to work in C#. So strongly typed arrays, brackets says a storage unit for multiple pieces of information. Yes?
So last semester during our final, we had the React app.
Yep.
Right?
Yeah.
Numbers, your name, someone else's anything.
Yeah.
In C#, like mix and match.
Is it possible? Yes. We're going to learn how to do that kind of later in the semester. Yeah. It is possible to have more flexibility there. But like right now, we're not going down that path. Okay, so how many students did we say Rankin has? 2,000. So the syntax here, we have the keyword new. And so this is a syntax for creating an array with, well, I said 100, but of course, we said there's 2,000 students. And so I'll put the number 2,000 in there. So that number 2,000 at the end of line 7, that says how many things, how many pieces of data you can store in this array. They give that a term. They call this dimensioning an array, right? So programming terms, obviously you got to know them. What does it mean to dimension an array? To dimension an array means to say how many pieces of data you can store inside of that array. Okay, so far so good? This is the first step to learning arrays. How to declare them, why are they important? Because it makes your software scalable, right? If statements make your program smart, loops make your programs powerful, arrays help to make your programs scalable. They can grow. This is called, putting that number in there means that this array can store 2,000 pieces of information. Right now, all of these names, if I were to print them at the console, either I get a compiler error or it's going to come back null. I believe the answer is null. Let's kind of just look at that. If I do a console.writeLine and I say student first name sub 0. Now, let's talk about what I just did here. I'm trying to access a piece of information. Well, I haven't put anything in there first. I haven't put any names in there. And I'm trying to just print something out. If I run this, I'm expecting it. Yeah, it's not even coming up. It's coming up more. It should be null.
Is that because the string is a reference type?
Yeah, it is a reference type, and so not important. But this doesn't really work. Let's take a step back. That's how do we put information into this, right? Because if I had a string variable, you all know how to put information into a string. How do I put information into an array? You have to use the brackets again. And I kind of showed the syntax a little bit right here. Let me go ahead and put some information. I'll say student first names brackets 0 bracket equals Bob.
So 2,000 like sets how many spaces there are?
How much space in RAM?
Okay.
Yeah, how much space in RAM? There's basically 2,000 spaces, variables worth of space. Now, it's gonna like dynamically fill that. Yes.
So if you put the brackets in the end there to signify how much data is going to be stored in the string.
Yeah, this one, right?
What exactly is the 0 for? Is it like assigning like a number out of the 2,000?
That's right. That's right. So what does the 0 represent? If you view the 2,000, you view the array as a warehouse of information, and there's 2,000 spots in this warehouse. There's 2,000 storage units in this warehouse. The first storage unit, see, programmers are weird. Did you know this? Programmers start counting at 0. Hopefully, well, it doesn't really matter. If you've never heard that before, programmers are weird. They start counting at 0. It's just something new. If you don't start your counting at 0, like I'm teaching my daughter to count, she starts at 1, but she's not a programmer yet. When she becomes a programmer, she will learn to start her counting at 0. We're weird. This elevator right here, it's kind of a weird elevator. I like it though. It starts counting at 0. The ground floor is the 0 floor. Right? I don't know if anybody has noticed that, but this elevator was made by a programmer. Right? So this is, even though if like you're counting the number of floors in this building, this floor would technically be the 3rd floor, right? Because there's a ground floor, which is 0. The floor beneath us, they count as 1. Okay, moving on. Programmers start counting at 0. Arrays start counting at 0. Therefore, Hussein says, what does the 0 mean? In our warehouse of storage units, 0 is our first storage unit. Does that make sense? Answer your question? So we're saying, hey, in our first storage unit, put a value of Bob. So let's break this down. Line 7 declares and dimensions an array. This line, line 11 now, assigns the value of Bob to the first storage unit in the array, aka position 0, also known as position, also known as subscript 0. Any Mortal Kombat fans? Sub-Zero freezes people. This is Sub-Zero, right? Student first names, Sub-Zero, right? Subscript 0, Sub-Zero, first storage unit in our array. So you call these subscripts. New language, we're learning new terms, right? Dimensioning arrays. So sometimes when you see these brackets, you're dimensioning your array. Sometimes when you see brackets, you're referring to a subscript. When you say a subscript, you're just talking about a single storage unit. Write that one down. When I say subscript, I'm talking about a single storage unit inside of the array. So when I say Sub-Zero, it'd be like, again, going back to our warehouse analogy, I'm giving you the key for the first storage unit, and you can go put something in that storage unit. That's the position 0. Right? So all we're doing here, declare and dimensioning an array, we're putting a value into the first storage unit. So data goes into the array. It's very simple. You say, hey, I'm going to store data here. You put data in, you pull data out. That's all we're doing on this. We're putting data in on line 11, and now we're pulling data out. It's very similar to what we did with variables. It's the same concept. We're just putting data in and pulling data out. Right? So now if I run this, of course, we get the value of Bob. And we can take a little bit of what we learned about these fun terms, string interpolation, right? Our first user's name is student first names Sub-Zero. And, these arrays can go in these curly brackets just like any other variable.
We got a ran out Bob, Carl, 2009.
Ah, great question. It's Friday morning. It's hard to be awake and alert as a young college student. Daniel's awake. He asked a good question. He said, hey, if I got 2,000 students, do I need to write 2,000 lines of code to put all my student names in there? It's a good question. And I'm going to answer that with another question. Have we learned a control structure to help us do something as repetitive as putting a bunch of names in? Loops. Don't cuss.
Sorry.
But that was funny.
I don't think so.
Exactly.
Define God.
We got to stay business casual here. We gotta, but that was funny. So, arrays and loops are BFFs. Yeah? They're best friends. They work together, peanut butter and jelly. They go together like peanut butter and jelly. Okay? That's why we did loops first. Because they're pretty much co-requisites of arrays. Like if you're going to learn arrays and you're going to work with arrays, you're going to work with loops. So that's why you need to finish the labs from chapter 5, part 2, before starting arrays. And we were doing some of the labs, and some of you got to that lab of chapter 5, part 2, where you were doing the multiplication table. And I kind of said this to a couple people yesterday. I said, hey, if you can do that last lab, that last lab is tough on that chapter, but you will have a very firm command of loops if you're able to finish that lab and understand it. Right? If you are certainly ready for arrays, even if you can't finish that lab, because that's a tough lab, you're ready for arrays. Now, all that being said, yes, that's the answer to your question. Okay? So, if that's how I put information in the first storage unit or the first subscript, any guesses how I put information in the second storage unit? So student first name sub 0 is my first student name.
Student first name sub 1.
Okay, that's exactly right. So if I want to put someone up in Visual Studio is smart enough, it's kind of suggesting to me to put in student first name. This is called sub 1. And here we go. Let's put in Jan. And student first names sub 2 is Chris. So now I put 3 of the 2,000 student names in. I don't want to jump the gun, but there's a lot going on here. I guess if I had to go to the next step, I might say, keep in mind, this is an array with a strict data type. This is an array of strings. Just to prove the point, if I try and say student first name sub 3 equals 1, 2, 3, I get a red squiggly, right? Why does 1, 2, 3 not work? Well, of course, 1, 2, 3 is an integer. Data types don't match. On the left, we've got a string array, or it's looking for a string. On the right, we've got 1, 2, 3. Yeah. Anything inside of quotes will work. So if you put that in quotes, it absolutely will work. Along with whatever else you want to throw in there. Good observation. So it's got to go in quotes if it's a string. So you can have an array of strings. You can have an array of int. Student ages equals new int array. And let's kind of start it off at 0. Well, we need to dimension it with 2,000. And I'm just using the number 2,000 because roughly that's how many students Rankin has. Same thing. You can have an array of chars. You can have an array of float. You can have an array of double. You can have an array of long. You can have an array of all of our data types. You can have an array of Boolean. You can have an array of objects. We haven't really dealt much. Date times, yes.
Little off topic. Is there a method to convert to Unicode?
Is there a method? Not that I'm aware of.
Okay.
Yeah, not that I'm aware of. Yeah, so here's like an array of dates. Like we haven't really learned that there's a date time object, but there is. And this would be 2,000 dates. Store dates and times.
We need the brackets right after the first date time.
Actually, this is of course. My syntax is off a little bit. Oh, of course I need brackets on this. Yeah, good eye. Derp. You need brackets on the left and brackets on the right. Okay, and an array of objects, there's like another step, and we don't really need to cover that quite yet because we haven't even learned about objects. But this is object-oriented programming, so you know it's coming. All right, so actually I was going to resume, and I did notice one's missing, so I'm going to wait.
I don't want to sit watching you wait for 4 hours.
So I guess if you had to just, flush this last piece out, you could say, okay, put in 4 pieces of data and pull them back out, right? So you might guess what that's going to do. and that puts the users in 1, 2, 3, and 4. This you're going to notice if there's 2,000 storage units. But since we start our count at 0, it's worth noting that the subscripts count from 0 to 1 less than the number of elements, or as you would say, the length. So here, in this example 2000, our subscripts are 0 through 1999. If you have 10 elements, it's 0 through 9. If you have 20 elements, it's 0 through 19. If you have 50 elements, it's 0 through 49. 0 through 49. I want to show you, if I try and put something in a position 2000, very common mistake. Very common mistake. Put something in position 2000, and we'll put Hussein, who's walking in late from break. Hussain. We'll put Hussein in position 2000. This will break because there is no position 2000. It's 0 through 1999. And if I try and print this out, you're going to get an error called out of bounds. We're out of bounds. If you've ever played a sport, you've gone out of bounds. Out of bounds. Array was outside the bounds of the array. Index was outside of the bounds of the array. So this is a very common mistake that developers make. They think because there's 2,000 positions that they can store something in position 2,000. It doesn't exist. We are weird. We start counting at 0. Because we start counting at 0, that's called an off by 1 error. You're off by 1. It's 0 through 1999. All right? Yeah.
So, like, let's say instead of 2,000, they...
All right. So, that shows off by 1 errors. The next thing I want to do is show, kind of like clean this all up. And I'll just, I'll bring it back down to a smaller example. I'll say I'm going to have a string of first names equals new string, and I'm going to say there's 10 first names. Now, what are their subscripts? Their subscripts are 0 through 9. Okay, cool. I'm going to do one more thing. I'm just going to make a non-array, and I'll say teacher name. This is a singular, and I'll put my last name in it. I demonstrated in a prior lecture how to loop over a string. Remember doing a for loop, for tab, tab? Notice teacher name dot length. Let's talk through these. I'm going to even comment out my array. Let's not worry about the array right now. Let's just review something we've already talked about. I've got a variable. It's a string. It says teacher name Gudmested. How many characters are in there? Well, I don't even know. I think there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 characters in my last name. So teacher name dot length. Remember I went around the room and I said, what's the length of your name? And you just counted the number of characters, right? So teacher name dot length equals 9. I could hard code the 9 there, right? That loop would still work the same. If I just hard coded the 9 there, I could put that, or I could put teacher name dot length, because teacher name dot length equals 9. Okay, it's actually better to put teacher name dot length, because that way if you change something, like if I add a space at the end, now the length is 10. Maybe that space is relevant and I want that space in my name. Okay, so it's better to code a length property than it is to code a hard number. For that reason, the length property is considered dynamic. It can change, but a hard-coded 9 is not going to change unless you manually go back and change it. So now if I just do a council.writeLine teacher name sub I. Now I demonstrated this before, and what does that do? What does teacher name sub I do? We're going to get into, this is where loops and arrays are best friends. And teacher name sub I, when you see this, we have an array and its index is a variable that's changing. I is the iterator variable that's changing every time through a loop. So if I can get everyone to zone in here on line 13, please give me your attention here. This kind of syntax where you have an array and you're going, wait a minute, what array? But let's just focus. There is an array here and I can explain where that array came from. Where you're using this I that's a variable in a loop to change the subscript. This is how and why arrays work with loops. Because it allows you to use an iterator variable as a subscript. You can use the iterator variable as a subscript to change the position or position the element of the array each time through a loop. All right, now some of you might be wondering, an array, a string like teacher name, here's the one missing link that I haven't filled in. A string is automatically an array of chars. So sub 0 of teacher name is my G. Sub 1 is my U. Sub D, or sub 0, 1, 2. Sub 2 is the D. Right? So this loop, question for the class, someone raise their hand, give me an answer. How many iterations will this loop have? It's a count controlled loop. How many iterations? Yes. It will be 10. You're right. Why is it 10? Because there's 10 length. If you include the space, you're right. If you include the space, there's 10 characters. I'm going to delete that 10th character as 9 now, right? But you're right. The length of my name is 9. This is going to loop 9 times. The iterator variable starts at 0. What did I just say today about programmers are weird? We start our count at 0. Well, it works really well because guess what? Position 0 is the letter G. Then I goes to 1. Position 1 is the letter U. So on and so forth until I is 8. Position 8 is the D. I becomes 9. Is 9 less than 9? That is false. Therefore, the loop is done. Right? So this is actually a line of code that I wrote earlier, and I didn't really explain it like I just did, but I did the same kind of thing, where I used a loop to iterate over a string, one character at a time. This is something that we did, and if you're still stuck on the vowels program, counting the vowels, right? This could kind of get you unstuck. You could say something like if teacher name sub I equals, it's a char, the letter A. Let's make another variable called vowel count. Int vowel count is 0. If teacher name sub A or teacher name sub I is A, vowel count plus plus. Okay, so all I'm accounting for is the letter A here. Council.writeLine vowel count. Okay, and you can see I've got one A in my name. It counted the one letter A. So this is the trifecta that I need everybody to be able to do. The trifecta in this class, right? The trifecta in this class is this concept. We've got loops combining with arrays, which is right here, combining with if statements. When you can work with those three things together, that is a trifecta that will help you do well in this class. Those are three concepts: loops, arrays, and conditionals, that are very foundational to this class. All right, this is the trifecta.
And what does the plus plus mean? What does it mean?
That just makes a vowel count go up by 1. Plus plus makes it go up by 1. It is to say, take the current value of 0 and make it go up by 1. Increment it by 1. Yes.
This might be a dumb question.
No dumb questions. Well, that's what everyone says. I don't know, but that's okay. No dumb questions.
Does the existence of a plus plus infer that there's the existence of a minus minus?
There is yeah, there's absolutely a minus minus. Yep.
Okay.
Yep. No, it's not a dumb question.
Some languages even have a times time.
There is no times
No?
times.
That's not like JavaScript.
There are, well, you know what? You will see some of that. You're right.
Maybe not in C#.
Yeah. Okay. Right.
Modulus.
Yeah.
The
So,
remainder of the remainder.
so
I mean,
what we learned here was that a string is automatically can be converted into an array of chars. A string can be automatically converted into an array of chars. I demonstrated that by saying teacher name sub 0 equals the char letter A. I know that's the char letter A because it's in single quotes. Double quotes for strings, single quotes for chars. Okay? But instead of looping over a string, as we've done, let's loop over some first names. I'm going to bring in 4, and notice my autofill is looping over first names.length.
How do you get the autofill?
Tab. So I'm going to type in the word for, F-O-R. I'm going to hit tab twice.
Okay.
And normally it autofills all the way. I had to hit tab a few more times. But tab is the autofill. It's going to put in a code snippet for you.
Doesn't while do it as well?
Yeah, if you type in the word while, tab, it kind of puts in a code snippet for a while loop. There's a lot of code snippets that we'll keep using. Okay? All right. Same question goes to the class. How many iterations will this for loop have? 10. What will the subscripts be? 0 through 9. I will represent the values 0 through 9. Why is that perfect? That is perfect because those are the subscripts of our array. We just learned that there's 10 elements and their subscripts are 0 through 9. That's why arrays and loops are best friends. So here's what we do. Council.writeLine. What is your first name? If we're going to actually prompt the user for input, I'm going to change my array because I don't want to do this 10 times. I'm just going to do this 3 times. I've got an array of 3 first names. Now this loop automatically, dynamically, is looping 3 times. Instead of 10, it's looping 3. Because we use the length property, which is the recommendation, not a hard-coded 3 or not a hard-coded 10. Do you guys see the benefit to that? There's a benefit to that. So now we're going to prompt the user. What is your first name? We're going to assign first names sub I. This syntax right here, you have to understand the first part of this lecture to understand the second part of this lecture. We're kind of progressing into the second part of this lecture where we're using this iterator to represent an integer 0 through 2. So it's going to be 0, 1, 2. First name sub I equals console.writeLine. Oh, excuse me. Console.readLine. Okay. So this for loop is used to put data into our array. This line declares and dimensions our array. So we declare and dimension our array to say, hey, we've got 3 storage units. We use this for loop to put data into our array. Now, of course, yes, sir.
Okay, so you know last time with the first part where you were like literally coding like sub 0 and then 1
Yes, yes.
and 2. Does this I represent all 3? So
Absolutely
therefore
correct.
You don't have to put like
Bingo. Bingo. You hit the nail on the head. Yeah, that I represents the hard-coded 0, 1, and 2. Great question. 4. I'm going to hit 4 one more time. I'm going to make another for loop. And now we put, it's very simple at this point. I'm trying to keep it simple. Declare and dimension an array, put data in using a loop, pull data out using a loop. Put data into our array using a loop, and pull data out using a loop. Now notice this one, it's kind of barking at me because the code snippet doesn't really know the length of what. Of course, it's the length of our array, just like we had on line 12, first names.length. Okay? I wanna just very briefly mention there's a length property of an array, as we're demonstrating, and a length property of a string. Strings have a length, which means the number of characters. Arrays have a length, which means the number of elements that they can store. Does everyone kind of hear me on that one? There's a difference between the length of the string and the length of the array. The length of the string is how many characters are in the name, or in the string, I should say. The length of the array is the number of units that it can store, right? It's different, just enough. It's not a huge difference, but there's a difference there. Okay, first names.length, we're looping over here. And let's say council.writeLine, and we'll do our string interpolation. That is the word of the month. Thanks for using my program, and then I'll say first name sub I. Okay, doesn't really matter. I'm just showing you that you can put 3 names in with a loop, and you can pull 3 names out using a loop. And if I demonstrate this, and we've got Tim, Tom, and Tori. Is there an EY on Tori? Just a Y. Let's do a Y. Thanks for using my program, Tim. Thanks for using my program, Tom. Thanks for using my program, Tori. Right? Now with this is how our programs are scalable. Because all I have to do is change this to 100. Now I've got a loop 100 times, putting 100 people's names in. And I've got a loop going 100 times, pulling 100 names out. By changing one little number, right, my program just scaled to store a lot more information. And I don't have to write 100 variable names with 100 lines of code for each variable.
Because they do it for you.
Because the loops handle it for me. The loops handle it for me. Again, I want to kind of go back to what I would call the trifecta, where you're using arrays, loops, and conditionals. And to do the count vowels lab in chapter 5, one potential solution would use this trifecta. So here I've got some names, okay? I've got some names that I'm going to allow the user to put in. I'm going to do an if statement inside my for loop, and I'm going to say if first names sub I is Max, because I got Max looking at my board, so I'm going to use Max. 2 X's, yeah? Max.
Yep.
So here, if the first name is Max, console.writeLine, we're going to give Max a unique message, and we're going to say, thank you for paying attention, Max. Okay, because I know at that point I already know it's Max. 2 X's. Just a unique message. Otherwise, if your name isn't Max, for this program we're going to say buzz off. Console.writeLine. Hey username. Hey first names sub I, comma, you can buzz off. Yeah? Okay. I need a semicolon right here, and that makes everyone happy. What have we demonstrated in here? It's the trifecta. We have an array of first names, we have a loop, and more specifically, inside of my loop, I'm checking for something. In this case, I'm checking to see if one of my users is named Max. And if I do that, I say MAXX, and then I say Bob, and I say Bill, and I say Tom. Oh, wait a minute. Why do
change that to
I really don't want 100? I really don't want 100 names. Let's just bring in 3 names. I'll say Bob, I'll say Bill, and I'll say Max with 2 X's. Hey Bob, you can buzz off. Bill, you can buzz off. Thank you for paying attention, Max. This is the trifecta that you're going to get tired of hearing me call it the trifecta, but it is what is a very important skills to be able to piece together. Now, question for the class. If I say Bob and I say Bill and I say MAX, is that going to work? Nope. MAX can buzz off. What if I say Bob, Bill, in lowercase MAXX? Is that going to work? Nope. Lowercase MAXX can also buzz off. So some of you have come across this kind of thing where it's like, hey, this is what you would call a case-sensitive search, right? I am searching for a first name, and it's case-sensitive. And some of you say, well, I don't want it to. I want to allow my users to type in a capital letter or a lowercase letter. In other words, a case-insensitive search. And so what you can do here is take whatever the user gives you, go ahead and put it in. And I store a capital letter or I store a lowercase letter, however the user types it. But then on my test, when I'm testing first name sub I, well, first name sub I is a string. Turns out there's a method we haven't learned. But if you did some digging, you could hit the dot. And if you kind of dig through this, you can see this 2 lower. You might guess this is a method. It tells you to put parentheses on it. And then I can test it against, I know the whole thing's going to be lowercase. And now I'll test it against lowercase. So it's lowercase on the left, it's lowercase on the right. Then I'm performing a case-insensitive search. Even if I type in capital Max, or I type in lowercase Max, or I type in Bob, it doesn't really care if Max is capitalized or not, because I'm doing a case-insensitive search by taking whatever the user gave me and converting it to lowercase. And you can do that on any string. Any string can be converted to a casing with this 2 lower or 2 upper. We are approaching 1 hour, and we've covered a fair amount, so this is a really good stopping point for today. So I'll stop the recording here on the introduction to arrays. Is there more to learn? Absolutely. Absolutely. Is this a really good start? If you were able to follow along today and understand most of it, you're going to be in a good spot.